So today we will discuss demultiplexer. Demultiplexer will have only one input and will have n number of selection lines, 2 power n output lines. So it is what exactly? It is opposite to the multiplexer. What you have seen with respect to multiplexer? What we have seen with respect to multiplexer is something like this. What exactly we did it is, there will be 2 power n input lines, there will be one output line, there will be only one output, there will be selection lines, the number of selection lines equal to n, so there will be n selection lines, there will be 2 power n input lines. So these input lines are 0, 1, 2, 3, dash dash up to 2 power n minus 1, only one output y, which is just we have written like this. What we did? Just we have twisted it. We have made the output as input, then input as output. Okay. So in that case, what exactly we are calling? So far we are calling this as mux. But what we did is, we made output as input and these are actually inputs. So we have made input as an output. Selection lines remain same. That is nothing but demultiplexer. So whatever the data that you multiplex using multiplexer, we need to demultiplex it, because of which we always use in pairs. Okay. Whereas here mux will convert parallel data into serial form. Once data is made in serial form, at the receiver we need to convert serial data into parallel form. So for this reason we are going to use demultiplexer. Example demultiplexer. One example, if I take n is equals to 3. What is n is equals to 3? 2 power 3 is 8. So 1 is to 8. 2 power n. Let's take n is equal to 3. 1 is to 8. Right? So in 1 is to 8, there will be 3 selection lines. 3 selection lines because n is equal to 3. There is only one input and there will be 8 outputs. 0, 1, 2, 3, 4, 5, 6, 7. This is your input for sure. These are your outputs, of course, and these are the selection lines. Okay. For this, if at all I want truth table, what is truth table? Input output relation. So what is input is 1. There is one input. Let's say input A. There are selection lines. What is the selection lines we have? Say S0, S1, S2. What is S0 is LSB. What is S2 is MSB. Now how to write the truth table? Truth table. Inputs versus output. How many inputs we have? One input. This I can say data line or A, whatever it may be, but generally we use D, data line. Okay. So data line D, is there an enable input? There is no enable input. If at all we add, if at all you want, we can add it. If at all I add this demultiplexer, if at all you put a enable here, this demultiplexer becomes decoder. How it is? What is decoder? You will see later. Okay. So there will not be any enable input for demultiplexer. Now let's take the data in selection lines S0, S1, S2, and you have output. What are the outputs? What are the 8 outputs you have? So 8 outputs, say I say Y0 to Y7. Write them as Y0, Y1, Y2, Y3, Y4, Y5, Y6, Y7. Let's see, let's explore how it is going to function. Let's say I keep data is equal to 1 forever. Always I keep 1. Assuming that a serial data coming into the demultiplexer is always 1. It can be anything, but as an example I am taking 1. If that is the case, now look into the data lines. selection lines. Then look at the output. When 0 0 0, what is the meaning of that? The meaning of 0 0 0 is whatever is coming on the data line will routed to y0. So then output will be 1, rest of them will be zeros, 0 0 0 0. Next, this is 1 0 0 1. This is 0, this is 1 0 0 0 0 0. Next, if this is 1 0 1 0, 0 1 0 is much. What exactly it is? It is selecting, sending it to y2. So this will be 0 0 1 0 0 0 0. Next, input is still 1. What exactly is 0 1 1? 0 1 1 is y3, y3 being 1, rest all being 0, 0 0 1 0 0 0 0. 1 1 0 0. What is 1 0 0? Is 4. Where exactly input is routed to? Input will be routed to 4. So 0 0 0 0 1 0 0 0. Likewise, you have to go for all possible combinations. Okay. So 1 1 0 1 1 1 1 0, then 1 1 1 1. Okay. I am making for you people only. Those who are missing the class, they can go through it. Those who want to repeat the class, they can repeat it. No issue. If whatever the gimmicks you do, I will cut it. Don't worry. Okay. So 0 0 0 0. Whenever you are coming to the class, don't ask me. Just walk in, and don't make any noise. If you are able to catch the class, that is fine. Otherwise, you have a standby class. Okay. Don't make any noise. That's all. Anyhow, I have a noise cancellation also. Okay, but don't make noise. Fine. So we'll look into this. 0 1 0 0. What exactly the last case? The last input is 1 1 1 1. Then all zeros. Then last becomes 1. What is the meaning of this? Output is any one will be active based on the selection lines. Okay. Why I took always ones? To show that something is coming onto that particular line. If I take 0, by default, if nothing is there, 0 will be there. If 0 is coming, also 0 is there. So it is difficult to distinguish whether the data is there or not there. That is the reason why what I did is I took all ones and I have shown this. This is how demultiplexer is going to work. Okay. Same as multiplexer. Okay. Inputs becomes outputs, outputs becomes input. Number of selection lines are same. That itself is demultiplexer. Close it, ma. Stop it.